Welcome.
Yes, hi. My
Hi.
name is Julie Brigham-Grette. I
Yeah.
am department head at the University of Massachusetts in the Department of Geosciences, and I'm also the current chair of the U.S. National Academy of Sciences Polar Research Board.
And you know a lot about ice and
I've been working in the Arctic for about 40 years,
mm,
and from a time when I was doing my dissertation work by Zodiac, being stuck in a lot of ice, if I was doing that work today, I wouldn't have any problem with sea ice.
all right. Okay. So what can we learn from the ice?
Well, what we can learn from looking at the climate history of the Arctic is that that we can learn about how sensitive the Arctic is to a very small change in the environmental conditions. Earth's system responds relatively quickly in some aspects in terms of its response. So the fact that we see the current warming, that is human-induced warming today, is causing a dramatic decrease in the Arctic sea ice, is a perfect example of how quickly the Arctic system can change. And then we can also look at the use that sensitivity even looking into the past to kind of inform our future. So when was the Arctic ice-free before? What caused that? What did it take to make the Arctic ice-free in the summer in the past? And then learn from that to say something about how serious our future is.
Okay. How can you do that? How can you say something? I mean, the ice is just frozen water. How can you say something that has happened like 100,000 or a million years ago?
Well, there's when you lose for example, the Arctic sea ice, that has implication for particularly coastal processes. So where we see, for example, scientists have dated beach deposits in northern Greenland that date from around 8,000 years ago. Now, those beaches could not have formed today because today there's fast ice against the northern coast of Greenland in large part. So you can't form a beach. You don't have any wave activity. You can't form a beach.
If you have ice
covering the Arctic Ocean. But particularly if you look at climate models today, or particularly sea ice models, they would predict that the last place in the Arctic Ocean to lose ice in the summer would be the northern coast of Greenland. And yet here we have the geological evidence that 8,000 years ago, with only a small, tiny bit of natural warming, that in fact we probably lost all of the sea ice along northern Greenland. So today, what we're doing to the Arctic has to do with CO2 and the atmospheric changes that are inducing that warming.
Yeah.
And so we can probably predict that in the coming decades, we're going to be very seriously losing all of the ice in the summer across the Arctic.
Are
So-
we bound to? Yeah.
Well, yeah, we're bound to that. I mean, the estimates go from, like the earliest estimates I heard were from 2028, which is only 10 years from now, to more like 2035 to 2040. So that's another another decade or so. But that's how close we are. All of the models suggest that that's the trajectory we're on. As the sea ice melts, we're opening up large areas of the surface ocean that's going to absorb more heat. And so that heat will take longer to dissipate. We'll have more thinner ice in the winter. And of course, that contributes to the warming that is causing the melting of Greenland and the rapid melting of many of the coastal glaciers. And so we're seeing a process that is only running in one direction. There's not much in place that's going to turn it around unless we do something about our fossil fuel emissions.
And do policymakers and politicians and average people, do they understand this?
I don't think they understand the gravity of the problem and how urgent it is for us to respond with our decreasing fossil fuels now. We're kicking the can down the road, as we say, to passing it on to the next generation. But I think we are seeing now many places where sea level and storm surges are becoming a very serious problem. Not just every once in a while, but on a more frequent basis, and that's going to start to wake people up to how serious the sea level issue is, as among many problems with climate change.
And what time scale are we talking about?
Well, we're already seeing serious nuisance flooding in parts of Florida, but I think we're certainly we can expect that by the time today's first graders are 40, 50 years old, they're going to be experiencing at least maybe half a meter of sea level rise and a very conservative end. So even half a meter is tremendous. By the time they're elderly people, it could be a meter of sea level. So within one child's lifetime, we could see a meter of sea level rise. And I think we have to get it into that context so that people realize that, oh boy, we can't wait till 2050 or 2070 to do something about this. We have to start now.
Okay. Do you have any recent? I mean, what happened in the history, like 120,000 years ago, when we had about the same temperature, 1.5 degrees warmer than pre-industrial? So what was the situation then?
Yeah. So if you look at the last interglacial, which was slightly warmer than now, we lost a lot of the sea ice in summer. We saw the migration of marine organisms toward the north, and we also lost about 2 meters of global sea level out of Greenland. So we can see that, measure that response, and I think most scientists would agree that that's more or less the consensus that we have on that. And so it's kind of like, I like to call it a deja vu event, where what's happening today is mimicking exactly what happened 125,000 years ago, but for a different forcing, for a different reason. Today it's anthropogenically forced. Before, it had to do with the orbital configuration of the Earth. So we can learn from those past events about the future that we're driving.